Welcome to Excel 2013 Statistical Analysis video number 71. Hey, if you want to download this file and follow along, or the PDF file, click on the link below the video. Hey, last video was our first video in Chapter 11, and we talked about the sampling distribution of P bar minus P bar. In this video, we want to talk about confidence interval for difference between two population proportions. And if I page down 2 times, we're also going to do a hypothesis test for the difference between two population proportions. Now I'm going to page up. So I'm on page 3. We're going to start with confidence interval. Now we're trying to build a confidence interval for the difference between two population proportions. So what are we going to do? From sample data, we're going to calculate the point estimate for our population difference. And of course, that'll be P bar 1 minus P bar 2. We'll actually go take two different samples and calculate the proportions and then subtract them. That'll be our point estimate. And then we're going to add a margin of error to both sides to get an interval, lower and upper value. And that interval will contain the population proportion difference about 95 out of 100 times if we build a 95% confidence interval. Now, if we don't know our two population proportions, which we're not going to, we will use our sample proportions, P bar 1 and P bar 2, in all of our calculations. Now, if we're using sample proportions instead of our actual population proportions, when we calculate something like standard deviation, we did this last video, right? We got the exact standard deviation as if we had the entire sampling distribution of P bar 1 minus P bar 2. But when we start using our sample proportions in here to estimate our standard deviation, then we have to say, hey, we're estimating our standard deviation. Now, we're going to have to take two independent random samples. And for our confidence interval and hypothesis testing, we can use the normal distribution to estimate the sampling distribution of P bar 1 minus P bar 2 if our 4 tests are passed. 4 tests, and we've done this a few times when dealing with proportions throughout this class. Sample size 1 times sample proportion 1 greater than or equal to 5. And then sample size 1 times the complement. Both of those are greater than or equal to 5. And then we have to do the same 2 calculations for our sample 2. If all 4 of those are greater than or equal to 5, we can use the normal distribution. Now, here is our formula for our confidence interval. We have some point estimate plus or minus z times standard deviation. Our point estimate will be P bar 1 minus P bar 2. Remember, that's pointing towards the population proportion difference plus or minus z alpha divided by 2. At alpha divided by 2 just means this is the upper z. That's the number of standard deviations times our estimate of our standard deviation or standard error. We saw this formula last video. But of course, now we're going to be using our sample proportions to make our calculations. Now, when we make this calculation, we're going to do this first little part inside the square root in a single cell. Then we'll do this second part. This is the same calculation, but for the second population. We'll do those in 2 cells. And just like Chapter 10, when we did difference between sample means, we will then take the square root function in Excel and the sum function and simply add these. What we're going to do in Excel is make this formula much easier by using helper cells for that calculation and this calculation. All right, now let's jump over to Excel and see our example. Now, here's our example. An HMO wanted to check the accuracy of patient contact information data entry. The HMO took independent random samples of records and rechecked the accuracy of the data. So we have our results from the year 2013, the results from the year 2014. Now, each one of these samples is a different sample size. If I click in a cell here in the 2013 column and control down arrow and then scroll down a little bit, you can see we have about 316, but a lot more here. Now, control home to jump up to cell A1. Our definition of no will be no errors, data is accurate. Our definition of yes will be yes, errors were found. Our goal is to ask the question, is there a significant reduction in errors from 2013 to 2014? Now, P sub 1 will be the proportion for population 1, which we don't know, and P sub 2 will be proportion for population 2, which we do not know. P bar sub 1 and P bar sub 2 will be our sample proportions for the simple random sample from population 1 and 2. Now, here we're going to set this up just like we have in Chapter 10. We're going to make sure we have 1 and 2 in a certain order, and all of our calculations will follow this order. And by the way, some of the calculations matter the order that you do it, but some of them don't. But by being careful and setting up population 1, population 1, population 2, population 2 calculations, we're not going to get in trouble. Now, let's go ahead and count to get sample size. We're counting text, so I'm going to use count to count non-empty cells. Click in the top cell, Control-Shift down arrow, Control backspace to jump back, and now I'm going to hit Tab. So 316 equals count. Click in the top cell, Control-Shift down arrow, Control backspace, and Enter. 382 sample size. Now we want to count the yeses, and I have the criteria for yes there and the criteria for no there. We only have two options for this particular categorical variable, yes and no. So yes will be the P and no will be the 1 minus P. All right, so what do? We have to count with count ifs. We're not counting all of them, just some of them. So the criteria range, click in the top cell, Control-Shift down arrow, and I'm going to copy this, and I need to lock it. So I hit F4 key, and that locks the range, comma, and then I'm going to click on the criteria, which is a relative cell reference. That's so we can count yes, Control-Enter, and copy it down. If I click in the cell below and hit F2, I can verify. That remained locked, and now that's looking at no. So those are our two counts. Now we can count for 2014, count ifs. Click in the top cell, Control-Shift down arrow, F4 to lock it, comma to get to our next argument. Now look at this. I'm going to move this screen tip like this. I can't click right there, but I'm going to use my arrow keys and arrow over. If I couldn't use my arrow keys, sometimes if you click around in your formula, you can't use your arrow keys. You could then click on the cell above and then down arrow. All right, Control-Enter. Looks like we got 41 yeses. That means 41 of the sets of patient contact information had errors. When I copy this down, it looks like 341 did not. Now we can calculate our yes sample proportion. This will be P bar, and then the no's will be 1 minus P bar. So check this out. I'm going to say relative cell reference 2 above. That's the 45. It's the count for yes, divided by, and I have my sample size of 316, and I'm going to hit F4. That way I can drag this down, and the blue one will move to the no. Control-Enter, and copy it down. When you're doing this, remember, these are mutually exclusive categories, and they're collectively exhaustive, so they better add up to 1. And I can look down in the status bar, and I see a sum of 1. I could also click in the last cell and hit F2 to verify that the formula is looking correct. All right, you ready? Equals, hey, there's the number of yeses from 2014 divided by the sample size for 2014, F4, Control-Enter, and let's copy it down. I'm looking down at the status bar. I see sum of 1. I click in the last cell, F2. Boom, it looks like it's working well. Now we can calculate our point estimate. There's the proportion for yeses in 2013. There's the proportion for 2014. We've set it up as 1 and 2, so I'm going to say equals sample proportion for population 1 minus sample proportion of yeses from population 2. Control-Enter. So there's our estimate, about 3.5%. Now our goal is to build a confidence interval. So if this is the point estimate, we need to add a margin of error to either side to get our interval. Hey, let's go back to our PDFs and remind ourselves of the formula for confidence interval. There's the point estimate plus or minus our z, number standard deviation, times our estimate of our standard deviation for the sampling distribution of P bar 1 minus P bar 2. Now notice we have these two calculations. We're going to do them in two helper cells and simply add them inside the square root root function. All right, let's go back over to Excel. Now, before we can use the normal curve and z, we have to check whether p times n is greater than 5 and 1 minus p times n is greater than 5. But we do not have the population p, so we're going to use our p bars as an estimate. So equals, and I'm going to take p bar 1 times our n, and we need to lock this because I'm going to copy it down, so F4, and then I do my comparative operator. Are you greater than or equal to 5? Because I'm using a comparative operator, it'll give me a true or false. So I copy this down. Now I do the same thing over here. Hey, RP times our 380, F4 to lock it. Are you greater than or equal to 5? Control Enter and copy it down. So we have our 4 tests. They all come out true, so we can use the normal curve. Now I'm going to scroll down here. Now we want to calculate p bar minus 1 minus p bar divided by n for each one of our populations. Actually, I shouldn't have scrolled down as much. There we go. Equals, and here's the inside of our standard error estimate. I'm going to say p times our 1 minus p divided by our sample size. And notice those are relative cell references. When I copy this over, they'll move perfectly to population 2 data. Control Enter and copy it over. All right, so these are our 2 helper cells, 1 and 2, that we'll use in later calculations. All right, if we're given alpha of 0.05, our confidence interval is going to be 1 minus that. That means we're 95% sure that our interval will contain our population difference. Alpha divided by 2, because we need to talk about x on the upper end, so equals that 0.05 divided by 2. Now, let's calculate our z. Now, remember, we're talking about the standard normal curve. So I say equals norm.s, and it's the inverses that give us the values. Probability, well, wait a second. I need it on the upper end, so I need everything except for that last little bit there. So 1 minus 0.025, that'll give me the 97.5%. And when I Control Enter, there's our z. That's the number of standard deviations we're going to use for our margin of error. Estimate of standard error. Here's the formula. We saw it over in our PDFs. That's the whole little bit right there. That's the whole little bit right there. So I simply equals square root and then the sum. Remember, we did the same construction, square root sum, in Chapter 10 when we calculated our standard error. Simply highlight our 2 helper cells, and boom, close parentheses, Control Enter. There is our estimate of our standard deviation for the sampling distribution of p bar 1 minus p bar 2. Now, our margin of error, number of standard deviations times our estimate of standard deviation equals, hey, number of standard deviations times estimate of our standard error, standard deviation. That's the margin of error that we're going to add to either side of this. So the upper becomes equals, there's our point estimate, p bar 1 minus p bar 2. And this is the upper, so I add the margin of error. Enter. Equals, there's our point estimate, p bar 1 minus p bar 2. And I'm going to subtract from it our margin of error. And there is our interval. We are 95% sure that the population proportion differences between those 2 values. So we can say, just as we have many times in this class already, we are 95% sure that the population proportion for the difference between 2013 errors and 2014 errors is between minus 0.0, like minus point, almost 1.5%, all the way to up to positive almost 8.5%. Now, as we've talked about a few times in this class, if we're doing hypothesis testing, if the interval contains 0, then we can say this. Because 0 is our interval, it seems reasonable to assume that there is not a significant reduction in errors. All right. Now, that's doing the confidence interval. We want to now talk about doing hypothesis testing. Now, I want to go back over to our PDFs and page down to go to page 5. All right, so hypothesis testing to check if there is no difference between 2 population proportions population proportion 1 minus population proportion 2. We're going to use the z method, and all the no difference means is that the hypothesized difference is 0. Now, from sample data, we run the 5-step hypothesis test. No difference between two population proportions. The 5 steps are exactly like we've done in the last couple of chapters. Now, here's a note about how we do it this section. Next section, we'll actually see how to compare 2 or more population proportions. Now, in this section, we run hypothesis tests for p sub 1 minus p sub 2 using z method. Next section, we'll see how to check the difference between 2 or more population proportions. Actually, the textbook says 3 or more, but you can do it with 2, so I put 2 or more. And the trick is we're going to be using the chi-square method. The note I just want to make here, and the note is in our notes for next section too, is the chi-square method only does 2-tail tests. Now, our z method here allows us to run the 3 types of tests. These are the same 3 types of tests we've done the same couple chapters. A 1-tail lower, 1-tail upper, or 2-tail. Now, last chapter, chapter 10, we did mu sub 1 minus mu sub 2. Well, of course, we're doing proportions here, so it's p sub 1 minus p sub 2. That means population proportion 1 minus population proportion 2. Now, less than 0, that just means that the population proportion 2 is going to be bigger if we accept this alternative conclusion, because smaller number minus bigger number is going to be less than 0. Here, the alternative, if this turns out to be bigger, then that means the first one was bigger. Over here, this is a 2-tail. Now, we still must have 2 independent random samples. We're going to run our 4 tests. On our next page here, page 6 in the PDFs, we're going to look at our formulas. And actually, the strange thing is we're going to have a different formula for our estimate of our standard error. And we're going to have a way to estimate p. All right. And both of these formulas are contingent on the fact that we're going to assume that the null hypothesis, h sub 0, is true as an equality. That just means that p sub 1 minus p sub 2 will equal 0. Well, if we subtract these and they equal 0, that means they're exactly equal. So our assumptions for these calculations is that population proportion 1 will be exactly equal to population proportion 2, and we'll just call it p. So our formula for estimating standard error of our sampling distribution of p bar 1 minus p bar 2 is when this holds true. Now let's look at this. This is the formula we use for our confidence interval. We had p1 and p2, and we substituted our sample proportions. Well, wait a second. If that's equal to the p sub 2 here, then guess what? This is really p times, in parentheses, 1 minus p in both places. Well, we can simply factor that out, and there it is. We have this on the outside and left on the inside. Oh, well, if we factor this out, there's a 1 on the top. We factor that out, there's a 1 on the top, so we're left with this on the inside. And that's the formula we will use. Well, if we're going to use this formula for our standard error, we're going to need to estimate the p. Down here, this is called the pooled estimator of p when this holds true. It's going to be referred to as p bar, and it is a weighted average. If you remember back from chapter 3, we have a count, which is our sample size, times our sample proportion 1, plus the count or the sample size for sample 2 and the sample proportion 2. We divide that all by our count plus our count, or in our case, sample size plus sample size, and boom, that is a weighted average. We're going to refer to this as p bar. And if you remember, in our confidence interval, we had p bar sub 1, p bar sub 2. This means pool. We don't have any sub 1 or 2 because we've pooled both of them into a weighted average. That means our z, our test statistic, will be, there's our point estimate, and we take the square root of p bar times 1 minus p bar. Remember, those are our weighted averages of both sample proportions, and we multiply it in parentheses 1 divided by sample size 1 plus 1 divided by sample size 2. Square root of all of that, that's our standard error or standard deviation. That's the point estimate. make that division, and boom, you have your z. So here's the formulas we're going to use for hypothesis testing when we're assuming that the two population proportions are equal. Now let's go over to Excel. Now we're actually going to do the calculations down here, but we have some numbers way up here we need. So watch this. We're going to learn a great trick. We don't need any of this stuff right here, so we're not going to delete it. I'm going to click on row 18 and come all the way down. And before clicking on row 38, I'm going to hold the Shift key and now click on row 38. I've highlighted everything in between. Right-click the row headers and point to Hide. All it does is hide it. It doesn't delete it, so hide. And you can tell it's hidden because our rows don't go 15, 16, 17, 39. There's some missing ones. They're hidden. Now we have the numbers we want, and we can start doing our hypothesis test. Now, our hypothesized difference is 0. And step 1, of course, is we're going to set up our null and alternative hypothesis. Now, we saw back in Chapter 9 how to do these letters with subs. But here it is. Null, colon, and then population proportion 1 minus population proportion 2. And then the alternative hypothesis, colon, and population proportion 1 minus population proportion 2. Now, these two values are going to be 0. We're going to put our comparative operator here like we've been doing for the last couple chapters. I'm going to highlight both cells, and in the active cell say equal the 0, F4 to lock it, and Control-Enter to populate that down through the cells. Now, remember, our question says, is there a significant reduction in errors from 2013 to 14. In our case, we're checking to see if 2014 went down, so that's P2. So this one's going to be smaller. So if we make the calculation biggest minus smaller, this better be positive. So the actual alternative hypothesis comparative operator is going to be space greater than. Enter, and I need to come up here and create our null comparative operator. We just switch it. Space, switch the comparative operator so it's less than, and equal sign always goes with the null hypothesis. Now we've set this up. Remember, this is pointing towards the upper end, so that means it's an upper test. If you hover your cursor here, I've already drawn the picture. This is going to be an upper end test. The upper end is where we have our reject the null and accept the alternative. If it doesn't make it past that hurdle, we fail to reject. Now there's our alpha. We want to go ahead and calculate our pooled estimate of P. We're going to call it P bar. Ready? Now, we can use the sum product because we were smart. We set these up right next to each other. There's two n's, n1, n2, and there's our two sample proportions. So I can simply multiply these two together with sum product, and then they'll add. So equals the sum product. I've set this up smartly, so I take my n's, comma, and my sample proportions for yes. Now that's the numerator. We now need to divide it by the sum of our n's. Those are our sample size. Remember, what does it mean when I multiply 316 times that? Well, I get 316 of those in the numerator and 382 of those in the numerator. Then I simply divide by the total count, and that will give us our weighted average. So there is our weighted average, 0.1232. And as we should expect, it should be somewhere between these two. Now our standard error, remember, we're going to take our new P bar, right there, times 1 minus P bar, and then do times 1 divided by the sample size 1 plus 1 divided by the sample size 2. So you ready? Equals square root. Hey, there's my new P bar. I need to take that and multiply it by 1 minus, so times, open parentheses, 1 minus the P bar. And I'm going to multiply this times, in parentheses, 1 divided by sample size 1 plus 1 divided by sample size 2. Close parentheses on that second orange one. Close parentheses on the square root. And when I enter, there is our estimate for our standard deviation of the sampling distribution of our P bar 1 minus P bar 2, or our standard error. Now we're ready to calculate our test statistic. Equals, and we take our point estimate. We hid the one there, or else we could use it, so I'm going to do it again. Oh, yeah. P bar 1 minus P bar 2. That's in the numerator. That's our point estimate. We divide it by number of standard deviations, and this will give us our test statistic, 1.403. Now we can calculate our critical value, our hurdle. Remember, this is the normal standard distribution. We have our probability, and this is a one-tailed test on the upper end. If we hover our picture, you can see that alpha on the upper end is 0.05. So you ready? Equals, well, it's the norm dot S for standard, and we want a Z. The inverses give us the values. We need the probability, not 0.05. That give us the value on the lower end. So 1 minus 0.05, and that will calculate our hurdle. Control Enter, and we can already see our test statistic is not past our hurdle. If we look at our picture, it's not there. So we're going to fail to reject the null hypothesis. P-value, well, there's our calculated test statistic. So we could get the probability of getting that value or more. It's still the norm, dot, it's still the S because it's a standard curve, and the dist gives us the probability. There's our Z. Remember, these functions always go from negative infinity all the way up to that value. And I'm going to comma cumulative. That tells it to go from negative infinity up to that value. That would give us all the probability up to this, but I want everything above, so I have to go 1 minus. Now we've done these kinds of calculations so many times in this class. We're getting used to it by now. Now when I hit Enter, now we can make our conclusion. And we'll come to the same conclusion we did with our confidence interval method. Because our test statistic is not past our hurdle and our p-value is bigger than our alpha, we fail to reject the null hypothesis. The evidence does not suggest that there is a significant reduction in errors. Of course, we do run a 5% risk that the null was not rejected, even though the alternative was true. Now, just a little reminder here, the advantage of the Z method, of course, is that we can do a two-tail or one-tail test. The disadvantage of this method, of course, is that we can only compare two population proportions. We could do more, but we talked about last chapter how we have a buildup of type 1 error. So next video, we'll talk about 2 or more, and we'll actually do a situation where we're comparing 4 different population proportions. Hey, in this video, we saw how to do a hypothesis test to compare 2 population proportions. We also saw, and this is important, I almost forgot. Notice it says 17 to 39. I'm going to highlight the 17 and then click and drag somewhere down past the 39. Right click and unhide. So the second thing we did was see how to create a confidence interval when we're comparing 2 population proportions. All right, next video we'll do 2 or more comparison of population proportions using chi-square distribution and the chi-square method. All right, see you next video.